Okay, let's see some more carbonyl additions, but let's think of it backwards. Sometimes you have a product and you have to think, how could I make that product by reacting an organometallic reagent with a carbonyl? So this is going to be our compound. We're going to have an alcohol, and we could make, that's the compound we're trying to make. And it's not very clear, but all those are supposed to be attached together at one carbon. So how do we get alcohols? We get alcohols by attacking a carbonyl. So when we look at this, we need to think of, here's this carbon is where our carbonyl used to be. And we have three choices. We could either put a methyl group on that carbon, an ethyl group, or a phenyl group. So let's look at these three ways. If we put the phenyl group on, that means our carbonyl started with a methyl and ethyl attached. So that means we started with this compound. And what did we treat this with? We must have treated it with phenyl. You could do an organolithium. Phenylithium would be appropriate. This then attacked. I'm going to finish it. The first step would be treating with the organometallic and then water. The first step, there's our phenylithium attacking. I'm going to draw the phenyl over here. And then step 2, we'd have the water. I've already shown step 2 over here, but now I'm going to bring in water as the reagent, and we'll get our product. That's one way we could go about this. Add the phenyl and have the methyl and ethyl already present. We could also have the phenyl and ethyl present and then add the methyl. So there's the ethyl on one side of the carbonyl. Here's the phenyl. And we could treat this with methyl. So what do we want to treat it with? Let's say we're going to treat it with methyl. Let's do a Grignard this time, and let's arbitrarily say it's the magnesium chloride. That's fine. And then we treat this with water. I won't go through the whole process showing what I didn't label up here, the tetrahedral intermediate, but we're going to attack with methyl minus. It's going to make the O minus, and then once we get the O minus, we'll protonate with water, and we will again get the same alcohol. And lastly, I think you probably know where I'm going on this. Let's say we already have the methyl group present and the phenyl group present. And we'll add the ethyl. So let's add the ethyl. This might be, let's make this the magnesium iodide. None of these are particularly better than the other. And treat with water, and again, we get the same product. So when you have multiple options, sometimes the big question is, okay, great, there are multiple options. Which one's the right answer? Okay, these are all appropriate answers. And if your job was to actually make this molecule in lab, you might go look in your inventory of chemicals and say, okay, great, I have this starting material and I can make this Grignard. I don't have that starting material, and maybe you can't make this organolithium, so you decide, okay, I'll make it this way. It's nice to have multiple ways to make things because sometimes you only have the materials on hand to do one pathway, not any pathway. So it's not a matter of which is best. Sometimes it's which is best according to what are the reagents I have on hand. But these are all valid ways to talk about making this one molecule. So having flexibility it's a nice thing when you're trying to accomplish a synthetic task.